Welcome back, noobs and pros. This is Kubernetes Notes, and I am Funny Chidela. In this episode, we will talk about node affinity and also talk about taints and tolerations briefly towards the end. Let's get started. While the scheduler automatically takes care of pod scheduling based on availability of resources, there are situations where we want to place a pod in a particular node or group of nodes. We can constrain a pod so that it is restricted to run on a particular node, or the pod prefers to be scheduled on a particular node. There are several ways to achieve this, and all of the recommended approaches use label selectors to facilitate the selection. Before we go into the 4 methods to achieve node affinity, let's talk about node labels. Node labels allow us to target pods for scheduling on specific nodes or group of nodes. We can make sure that pods run only on nodes with certain isolation, security, or regulatory properties. Now, as promised, let's talk about the 4 methods which can be used to specify the node affinity. These are node selector field. Second is affinity and anti-affinity rules. Third is the node name. And finally, we have pod topology spread constraints. Let's start with the node selector field. Using node selector field, we just specify the target node's label in the pod specification. This uses a simple and straightforward logic. Next, we have affinity and anti-affinity rules. These help us provide more expressive logic and gives us more control. The rule can be soft or preferred. This way, the pod get scheduled even if there's no matching node available. Using the affinity rules, we can also constrain the pod using pod labels of existing pods. This way, we can define rules about which pod can be co-located on a given node. Third method is node name. This is more direct form of node selection than the node selector field. Node name overrides node selector or affinity and non-affinity rules. But there are 3 limitations you need to know. If the named node does not exist, the pod will not get scheduled, and in some cases, it may even get deleted. If the named node does not have required resources for the pod will fail, and the reason will be specified. Lastly, node names in cloud environments is not always predictable or stable. The final method is pod topology spread constraints. We can specify these constraints to spread the pods across the cluster among different regions, zones, nodes, or overall utilization. We may need to do this to improve performance, expected availability, or overall utilization. Now let's talk about taints and tolerations. We specify taints which allow a node to repel certain pods from running on it. So we mention these taints within nodes. Tolerations, which we specify on the pods, allow the scheduler to schedule pods on the nodes with matching taints. Toleration does not guarantee scheduling. There are other parameters which the scheduler considers. Taints and tolerations work together to ensure pods are not scheduled on inappropriate nodes. Example use cases are: we can run pods on dedicated nodes. We can run pods on nodes with specialized hardware. And we can also evict pods based on the taint. So this is it for this episode. Thank you very much for listening to us. Please provide feedback. We are at CubeNotes on Instagram, KUBENOTES. If you like our work, you can support us by visiting buymeacoffee.com/Chintu. That is buymeacoffee.com/CHINTU. Thanks.
If you like this episode, please consider following us wherever you hear your podcasts.